Good afternoon, all. Today I'm going to explain you about CRO operation called cathode ray oscilloscope. How it is working for representing the output of a half wave and full wave rectifier output. Okay. First, we are giving an input signal through a function generator. A sinusoidal waveform is applied through a function generator to this to display in cathode ray oscilloscope. So you can see a sinusoidal waveform here, and now, the amplitude of the sine wave can be changed by using this volt per division. If you change the volt per division, you can change the amplitude of this waveform. Okay. So, now you can see a small amplitude. But the peak to peak value and amplitude will be always same if you change the volt per division. For the user comfortability, you can set either it 2 vertical division or 4 vertical division. Okay. So now we set it as a 50 millivolt and 2 division. So 100 millivolt is our peak to peak value of this voltage. Okay. And one to complete one cycle, both positive and negative half cycle, it requires 4 horizontal squares on this graph. So 4 into time per division is 5 milliseconds. That 4 horizontal division is taken for completing one cycle into time per division 5 millisecond is the time period of this waveform. So time period of this waveform is 4 squares into time period 5 milliseconds. So 20 millisecond is the time period of this waveform, and the frequency can be calculated by using this time period value. 1 by t is the frequency. And okay, and amplitude is number of vertical squares taken for both the positive and negative peak into volt per division value. Okay, so you can find out the value by using these waveforms. Okay, so now you can see a waveform, sinusoidal waveform. Now it is setting in not at a proper way. So നമുക്ക് അതിനെ ഒന്ന് കറക്റ്റ് സെറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് എന്ത് ചെയ്യണം? ഈ ഗ്രൗണ്ട് ചെയ്യുക ഈ വേവിന്. ഓക്കെ, there is a switch ground G and D is denoted as ground. So now you can set the X and Y axis by using this Y shift knob. So by changing this Y shift knob, you can set the axis at the center. And now release the ground node. Now you can see the waveform at a proper center of the axis. Now you can count the number of squares. So 2 vertical squares is need to cover this waveform, both positive and negative. So 2 volt per division, 2 is your square number of squares, vertical squares into volt per division. Value is your amplitude, and the number of horizontal squares taken for both positive and negative half cycles 4 into time period. To calculate time period, you multiply that number of horizontal squares with this time per division value, which is displayed here. So first knob is used to adjust the volt per division. Second knob is also volt per division of second channel. You know that we have to display both input waveform and output waveform. So one channel is used to display input waveform, another channel is used to display output waveform. Okay, then the time period is calculated by using time per division. The third knob is used for time per division. Time per division into horizontal number of squares to complete one cycle is time period. Okay, so now you can see both the waveform of a, if you want to if you want to display both input and output waveform, you need 2 axes. So to get 2 axes, just press this dual, mono and dual. First in mono mode, if it is in mono mode, you can display only one waveform. In dual mode, you can see another wave also. Okay, that means both input and output. Now I have connected the rectifier circuit also to this this to display our output of a rectifier. So now you can see both the input and output waveform of a our waveform. Okay, so now you can see both the axes. First we have to set both the axes. One axis to display input waveform, next axis to display output waveform. Okay. So നമ്മൾ രണ്ടും ആദ്യം ഗ്രൗണ്ട് ചെയ്ത് വെച്ചു. എന്നിട്ട് നമുക്ക് ഇതിനെ ഒന്ന് പ്രോപ്പർ ആയിട്ട് ഡിസ്പ്ലേ ചെയ്യാൻ വേണ്ടിയിട്ട് ഒന്ന് സെറ്റ് ചെയ്യണം. So first Y shift is used for first channel. Second Y shift is used for second channel. So first Y shift adjust ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് കാണാൻ പറ്റും. This axis is moving up and down. So now you can set the axis at a proper area to view the waveform. And another one can be changed by using this node. Now you set the another axis here. Now release the ground to display the waveform. Similarly, both the waveform. Okay. Now you can see the AC sinusoidal wave is our input and a smoothened DC output is obtained. Smoothened DC output. It is loosely connected. That is why it's not displaying correctly. Now you can see it's a smoothened DC output. Okay. So it is an output of a rectifier circuit. You can see this is the rectifier circuit. A rectifier circuit, full wave rectifier circuit with a filter circuit. So to connect it, to produce a rectifier circuit, we need two diodes. So we connected two diodes as a full wave rectifier, and the output of the rectifier is connected to a pi filter, two capacitor and resistor combination. So the output of rectifier is given to a pi filter and the output of filter is taken to display. So you get the smoothened output as the output waveform. കണ്ടോ നമ്മൾ റെക്ടിഫയറിന്റെ ഔട്ട്പുട്ട് നിങ്ങൾക്കറിയാം. ഇഫ് ഇറ്റ് ഇസ് എ ഹാഫ് വേവ് റെക്ടിഫയർ, ഔട്ട്പുട്ട് ഇസ് ഓൺലി അറ്റ് പോസിറ്റീവ് ഹാഫ് സൈക്കിൾ. ആൻഡ് ഫുൾ വേവിന്റെ ഔട്ട്പുട്ട് ആണെങ്കിലോ there is output at both the half cycle, positive half cycle ഉം നെഗറ്റീവ് ഹാഫ് സൈക്കിളിലും ഔട്ട്പുട്ട് ഉണ്ടായിരിക്കും. പക്ഷെ അത് ഒരു പൾസേറ്റിംഗ് ഔട്ട്പുട്ട് ആയിരിക്കും. ബട്ട് ഇഫ് we give the output of a rectifier to a filter circuit, so the output of a filter circuit will be like this, a smoothened DC output. Almost DC അല്ലേ ഇവിടെ ഔട്ട്പുട്ട് കാണുന്നത്. So നമ്മൾ കൊടുത്ത sinusoidal വേവിന് this rectifier circuit converted that sine wave into a smoothened DC waveform. AC is converted into DC by using full wave rectifier circuit with filter combination. So it is a kit of full wave rectifier circuit. So it is connected, the rectifier circuit is connected to a pi filter and the output of this filter is connected by using this knob to represent as the waveform in cathode ray oscilloscope. So input waveform, AC sinusoidal waveform is converted to a smoothened DC output. Okay. So to find out the amplitude, just multiply the number of vertical squares with the volt per division. To find out time period, multiply number of horizontal squares taken to complete one cycle with time per division. So you will get the time period. Frequency is equal to 1 by time period. അങ്ങനെ calculate ചെയ്യാം. Okay. Thank you.